Today we will do the differential equation of y double prime minus y equals e to the x. And we're going to use the reduction order to do this problem. So to start off, we will make this y double prime minus y equals 0, which we then can turn into m squared minus 1 equals 0, which then our m becomes plus or minus 1. So our yc equals c1 e to the x plus c2 e to the negative x. And this is our y1, and this will be our y2. So now we have our yp equaling vx y1 of x, which will equal v e of x. And so then we will get a yp prime of v prime e of x, because we're taking the derivative of that, plus itself, because that's how the chain rule would work, and we would get e to the x v prime plus v. Then we would take the second derivative, and that would equal v double prime plus 2v prime plus v times by e to the x, which we would get that by taking the derivative of that. So now we plug the y double prime, everything back into our original equation, and we get yp double prime minus yp equals e to the x. And so our yp equaled v double prime plus 2v prime plus v all times by e to the x plus our yp, which equaled v e to the x equals e to the x. And this should be minus, and that should be minus. So now we have v double prime plus 2v prime e to the x equals e to the x, and then we would have v double prime plus 2v prime equaling 1. And so if we make z equal v prime, we'd have z prime equals z double prime, so we'd have z prime plus 2z equals 1, which is in the standard form of z prime plus px z equals q of x, with our integration factor of e to the 2 dx equaling e to the 2x. And so then we have d of dx, and dz of e to the 2x z equaling e to the 2x. If we take the integral of both sides, we end up with z equals 1/2 plus c e to the 2t. We get this by the product rule. So we get this by using the product rule for derivatives in reverse. We get z equals 1/2 plus c3 e to the 2x. Then we'd have to plug our y equals yc plus yp. So remember, our yc was this up here. So our y equals c1 e to the x plus c2 e to the negative x plus our yp, which was 1/2 plus c3 e to the 2x. And that is our differential equation using the reduction order.